Hello, and welcome to this Run from the Light technical overview. This is a follow-up to the gameplay video available on my YouTube channel. In this video, I'll walk you through the main systems behind the project. Let's dive in. The player can target objects in two ways. Interactables are the actors close to you, like NPCs and levers, and aimables are actors you can target with the reticle, like statues and light sources. The interactable targeting component uses a sphere overlap around the player, which detects nearby interactable components. The focus component uses a camera line trace every 10 frames whenever the player is in focus mode. If I were redoing it, I would use a line trace for interactions as well, first of all to keep things consistent, and also to reduce overlap bookkeeping and performance cost. The player has multiple abilities: possess an NPC, stealth kill, teleport, corrupt a light source, and interact with various objects. All of them run through the same pipeline. Attempt action checks if we have a valid target and if we are executing a compatible ability on it. If everything is valid, it starts the ability animation montage, sometimes only on the player and sometimes as synchronized animation on both the player and the target. The ability logic is triggered when the animation hits the perform action notify. Once that fires, we can decide whether to run the core ability logic or perform a pre-action step first. This allows, for example, the possess ability to trigger SFX and VFX immediately, and then execute the actual embodiment logic after a set delay. And the delay is authored in the ability data asset. Each light that should affect the player has a light effect component attached to it. The component defines what kind of effect the light should have. On begin play, it registers itself into a global light effect subsystem, which periodically polls all registered lights and checks if the player is inside their radius. Creating a new light is very simple. You need a blueprint from the base corruptible actor class. From there, you configure the light effect component by defining what kind of gameplay effect it should apply. And after that, you assign presets for the base light data, the flicker behavior, and the overlay material. Finally, you add a point light or a spotlight component. The effect range is driven by the light's radius. The objective system handles directional hints, spatial audio feedback, and edgy lore. Everything from scale behavior to materials is authored in a data table. When an objective starts, it posts wise events on both the player and the target. As the player moves closer, an RTPC drives the guide intensity in real time. The VFX system is built around a reusable base VFX component that controls Niagara effects. Each effect is also defined in a data asset. When the VFX fades in or out, the system automatically posts the correct audio events and updates the RTPC value in sync with the visual alpha. This is already a long video, so I'll stop here, but this gives you a solid overview of the project. Thank you for watching and see you on the next one.